The second method we're going to use for solving systems of equations is called the addition method. And remember, a system of I keep saying and. The system of equations is just two or more equations. For our sections, we're just using lines, but you could have a parabola and a circle, or an ellipse and a parabola, or an ellipse and a line. We just concentrate on the linear equation. So we're finding that point where those two lines cross. That's what solving a system means in our purposes. So like I said, this method is called the addition method. Some textbooks also refer to it as elimination method. They're both good because we do add the equations, so that makes it addition method. And we also try to get a variable to eliminate, and that's why some books called elimination method. So you should be able to recognize it either way. You'll see it's very different from substitution method we just finished. They both give you the same answer, but the process is very different. So first thing we're going to do is write both equations. This is called standard form. You put the x and y on the left in alphabetical order, and you set it equal to the constant, the number without the variable. So we don't solve for one of the variables. Remember, step one of the substitution method was solve for the variable with a 1 in front of it. Don't do that now. We just line them up in order, x and y on the left, constant on the right. Clear fractions or decimals, that's just like our last method. And next step, we're trying to make opposites. Positive 3y, negative 3y. Negative 4x, positive 4x. So we're trying to make opposites. So we're going to multiply one or both equations by some number in order to make the x's opposites or the y's opposite. And then here's where it gets its name. After you make opposites, you add the equations together to eliminate one variable. So that's where the names come from. Then you solve for the remaining variable and then plug it in. So this step is also different from the last method. We substitute into the original equation. Remember, on the last method, we substituted into the box where we either had solved for x or solved for y. So we don't have that nice pretty box to substitute in now. We have to go back into the original. And then don't forget to check both equations. Because if you just check one, you might as well not check at all, because you need to show that it's a solution for both equations in order for it to be valid. So if I ran across this first problem on a test and it didn't say a method, I would use substitution on this one. Look at y is already alone. Boom, it's ready. Put 13 minus 3x in there. But the directions ask us to use addition method. So we're nice little rule followers and we're going to follow the directions. So step one, you need your equations in x plus y equals c form. So this one is easy to get there. All we have to do is switch those two around. So that'll be 9x. Oh, come on, Kim. 2x plus 9y equals negative 8. The other one, we have to do a little bit more work because we need this x over there. So let's add 3x, and then we have to add 3x here. So that's going to give us 3x, and then this would be plus, because there's no sign, 1y, and then that would be equal to 13, because the x's would cancel over there. So now we do have both equations. This is what step one says. Put both equations in standard form, so that's done. There aren't any decimals or fractions, so we don't need to do that. So we're ready for the big step. This is the most important step. Make opposites. And it doesn't matter whether your x's are opposites or your y's, either one. So let's see which one would be better. So when I look at this, I say, well, if I wanted to make the x's opposite, I could make this positive 6x and this negative 6x. So it's kind of like LCD. You're finding a number they both go into. So 2 and 3 both go into 6. So if I wanted to make this positive 6, I'd multiply the whole equation by 3. If I wanted to make this negative 6, I'd multiply this whole equation by negative 2. That's what they mean by opposite. Same number, different signs. Or I could pick the y's. This one's 9y. Oh, all I'd have to do is make the bottom one negative 9y. Done. So I'm going to pick that one because then I don't have to multiply both equations. But guess what? If you would have done 6x, negative 6x, we get the same answer at the end. I just saw this was a little bit easier because if this is 9y, I need this to be negative 9y. So multiply by negative 9. And probably the most common mistake on the addition method is students forget the number over here. So I recommend putting parentheses in, and then I also recommend in a different color just to draw your attention to it, the arrows to remind yourself to have to go all the way across. Okay, so we're trying to make the y's opposites. This is positive 9y. If I multiply this whole line by negative 9, I'll get negative 9y. So we have 2x plus 9y equals negative 8. That one doesn't change. And the next one's going to be negative 27x when we multiply by negative 9. Negative 9y. See my opposites there? That's what step 3 says to do. Make opposites. And I did, because opposites cancel. We don't know how to solve an equation with two variables, but if I can eliminate one of the variables, then I'm in good shape. So let's do negative 9 times 13. So negative 9 times 13 is negative 117 for the last term. So if you come out with a really ugly answer on the test and you're thinking, oh, Miss Norris wouldn't do that, this is usually where the mistake's made. Students forget to multiply that by the negative 9, so always check there first and make sure you did that. Okay, here's where the method gets its name. After you've made opposites, then you add the two equations together. So 2 plus negative 27 would be negative 25x. Negative 9y plus 9y, 0. Don't write y. If you write y, that means there's one y left, and there is not. It's 0. 9 minus 9, 0. So just, excuse me, eliminate it. That's why this is called the elimination method. Y's are eliminated. When the signs are the same, add and keep the sign over here. So then we divide both sides by negative 25 to get our x alone. So we get x equals 5. So then I come up here and in the x slot, I put my 5. I get my point ready because remember, your final answer has to be written as a point. Okay, so here's another decision. So your first decision is deciding which variable to cancel or eliminate. The second decision is which equation do I go into? And on both cases, it doesn't matter. We'll still get the same answer. I think the top one looks a little easier, so I'm going to use it. So y equals 13 minus 3x. So we just found x to be 5. So y equals 13 minus 3 times 5. So 13 minus 15 is negative 2. So we know that point checks into this one. So let's just do a quick check into the other one just to verify that it's correct. So x is 5 and y is negative 2. So what I'm going to do is just to do a quick check is I'm going to come right here and I'm going to write down what I type in the calculator, and then I can do it all in the calculator. So 9 times -2 plus 2 times 5, does that give me -8? So all I have to do is write that step, then I can do all the rest in the calculator. Actually, in my head, -18 plus 10 is -8. So -8 equals -8. So in 10 seconds, I did a check, and I can walk away now and know without a doubt that I got this one correct, because I checked the first point into here, and then I just did a quick check with the second line. Nice, huh? Okay, so on number 2, ooh, I'm liking number 2. How about you guys? Do you see why it's going to be pretty easy? So they're already in standard form. Boom, step 1's done. No fractions or decimal. Boom, step 2's done. So we're on step 3, which is multiply to make opposites. So multiply to make opposites. I look at the x's and I go, well, this is a 1x. This is -4. Oh, this one's too easy. All I have to do is multiply by 4, and I have my opposites. -4x, +4x. So I don't even need to touch the second equation. I could have eliminated the y's, but it would have taken more work. I would have had to make it 12 and -12, so I would have had to multiply both equations. But having a 1 makes it easy to turn that into the opposite of -4, which is +4. And then remember the hint I gave you? 99.9999% of the mistakes on this method is because students forget that. So always make sure you do your arrows to remind you. So this turns into 4x plus 12y equals 27, 108. And -4x, so the bottom equation stays the same, plus 4y equals 36. So have I made opposites? Yes. So I'm ready to add. Boom. Gone. No x. Don't write x. That means 1x. Don't write anything. They have eliminated. 12 plus 4, 16y. 108 plus 36, 144. Divide by 16, divide by 16. I think that's 9, but let's verify. 108 plus 36 is 144. Divided by 16 is 9. So we can go up here and go, oh, okay, well, we know what y is. So what I do, especially on a simple one like this, is I just check into both and make sure that I get the same answer for both. So let's do that. Y is 9. So this first one would be x plus 3 times 9 equals 27. So that's checking into the first. Checking into the second, make this 9. -4x plus 4 times 9. And you don't have to put them in both. So if you're rushed on a test and you see your time's running out, you only have to put it into one. But if you plug it into both, your check's done, so you don't have to come back and check it later. So it's extra 10 seconds, I think. So x plus 27 equals 27. Subtract 27, subtract 27. Looks like x is 0. So let's see if we get x equals 0 for the second one. If we do, we can go yes and know that we got it right and walk away the proud owner of a correct problem. So let's see. So we put 9 in for y. That's what we found. So -4x plus 36 equals 36. -4x equals 0. X equals 0. Ding, ding, ding. So we have just shown that is the correct answer.